giving you the difference between the times. They are calling it early and late. So the gap between them is going to be the time difference. Instead, if they say one part of the distance and other part of the distance, I would have been worried. We need something more to do it. So the key is to understand the condition and then plug in the necessary formula to solve for it. If you know how to interpret the condition, if you know what to apply, it gets a lot easier from that. Nothing complicated here, nothing too much to work for. You know the funda, you plug it in, and we are through. Hello folks, welcome to the next class in the series of Basics to Advance in Quant with the topic time, speed and distance. We have had one round of discussion on the basic concepts like relative speed, average speed, effective speed, conversion rates, problems based on trains, boats and streams, linear tracks, circular tracks, pretty much everything. Every fundamental idea that we need to know, we have covered it. So in this class, we'll take some questions that are in the easy to moderate level, and then we'll see how well we have understood the concept by applying those logics and try to solve them. So this class is all about solving a bunch of questions to see how well we have understood it. So without any further ado, let's get into the class and get them solving. So for every question, I'll give you like 30 seconds to read it. You have a read at it, pause the video every now and then to look at the question, solve them, and then get into the solution. You can have a look at the question that's displayed over here. And let's solve the question. To go with, the question says, traveling at 3/4 of his usual speed, Arjun reaches his office 20 minutes late. What is the usual time he takes to reach office? So every day he travels at a certain speed and he reaches his office at a usual time. But today he travels at 3/4 of his usual speed, and as a result he reaches his office 20 minutes late. So we can say that our distance is equal to speed into time. We know this. Let's say distance is the distance between his office and home. S is his usual speed and T is his usual time. But today the same distance is covered at 3/4 of his usual speed. Now the question is, what will be the time taken? We know that speed and time are inversely proportional. So speed increases, time decreases, speed decreases, time increases. We understand they are inversely proportional. So whatever value comes here, it's going to be the inverse value of it. Or I think about it, S into T is equal to D. I have 3/4 of S. So what should be here so that I can get back to S into T? Simply take the inverse. That will become 4/3 of T. So 3 gets cancelled, 4 gets cancelled. You will get back to S into T. So 3/4 of the speed results in 4/3 of the time. Now we can look at this T and then say, hey, this T, I can write it as T plus 1/3T. We can split it as T plus 1/3T. What is T? Is usual speed. So usual time. What is 1/3 of T? That's extra time. I'm looking at this 4/3T and saying, hey, I can think about it as T plus 1/3T. Where T is the usual time that he takes at his usual speed. This 1/3 of T is an additional time that has come this time around. By data, we know that that's 20 minutes. So you can nicely say 1/3 of T is equal to 20 minutes, or T is equal to 60 minutes. And that will be his usual time to reach office. Nice idea. Look at the relation between speed and time, inverse it, split it, equate it, and we have our answer. Very simple stuff. Nothing complicated here. Nothing too much to work for. You know the funda, you plug it in, and we are through. Right. We'll get to the next question now. So the next question says, have a look at it. I'll give you another few seconds to take a snap of it. Let's get going. So this question says, cycling at 12 km/h, Meera reaches her school 6 minutes late. If she cycles at 16 km/h, she reaches 4 minutes early. Find the distance between her home and school. to make it a little more easy to understand, I want to say, let's say her school starts at 9 a.m. Think about it as 9 a.m. That's her school starting time. Now, if she travels at 16 kilometers per hour, she is 6 minutes late. Says that you travel at 12 kilometers per hour, you reach school 6 minutes late, or she will reach at 9:06 a.m. if she travels at 12 kilometers. Now, if she cycles at 16 kilometers per hour, she reaches 4 minutes early, or she will reach at 8:56 a.m. if she travels at 16 kilometers per hour. Now, I'm looking from this perspective. If she travels at 16 kilometers per hour, she reaches at 8:56. If she reduces her speed to 12 kilometers per hour, she reaches at 9:06. Or I can say from 16 kilometers per hour, if she travels at 12 kilometers per hour, she takes 10 minutes more. Instead of reaching at 8:56, she would reach at 9:06, which means she is taking 10 minutes more. Or we can say the difference between their time will be 10 minutes. Time taken to travel at 12 kilometers per hour and then time taken to travel at 16 kilometers per hour, the difference is going to be 10 minutes. Let's say T1 is equal to time taken to travel at 16 kilometers per hour. T2 will be same time taken to travel at 12 kilometers per hour. We know that if you travel at 12 kilometers per hour, you will take more time, or we can say T2 minus T1 is equal to 10 minutes. Time taken to cover this distance at 12 kilometers per hour would be, we don't know the distance, so that will be d by 12 minus d by 16 is equal to 10. It's not 10. We have to understand this is in kilometers per hour, this is in kilometers per hour, this is in minutes. Cannot use minutes now, you have to convert it to hours. So I'm going to divide it by 60 and then solve for it. So 0, 0 gets cancelled. So the LCM will be 48. 4 times 12 is 4, or 4 times 48. So 1 into 4 would be 4. Minus 3 times 16 is 48, minus 3. I'm taking the d common out here. This is equal to 1 by 6. So 4 minus 3 is 1. I can say d by 48 is equal to 1 by 6, or d is equal to 48 by 6. That will be 8 kilometers. And that will be our answer. So the distance between the school and her home is going to be 8 kilometers. And that's our answer. Understand that that's given time, and that's, instead of giving you the difference between the times, they are calling it early and late. So the gap between them is going to be the time difference. We equate the time difference, we will automatically get to the question. Nice simple funda yet again. Learn it, apply it, and we get better. Right? We'll move on to the next question. Have a look at this question. Again, I'll step away for you to take a snap. And here we go solving it. A bus covers 1/4 of the journey at 48 kilometers per hour and the remaining distance at 72 kilometers per hour. Find the average speed of the bus for the entire journey. So the total average speed is always given as total distance divided by total time. So we can use that. What is the total distance here? The distance is not mentioned, but they are saying some distance, 1/4 of the distance and 3/4 of the distance. So we'll call the total distance to be d. So that will give us d divided by total time. 1/4 of the distance covered at 48 kilometers per hour. So the time taken would be distance by speed. 1/4 of the distance at 48 kilometers per hour. The remaining distance at 72 kilometers per hour. So that will be plus 3D by 4 divided by 40, 72. That will be our average speed. So let's solve for this. This will become d divided by 4 into 48 would become 96, 192 plus 3 will get cancelled over here 24 times. 24 into 4 will be 96, d by 96. I can take out this d common and cancel it over here. That will be like d divided by d into 1 by 192 plus 1 by 96. D get cancelled. We'll end up with taking LCM 192 and 96. The LCM itself is 192. So this will be 1 divided by 192. This will be 1 plus 2, or this will be 1 divided by 3 by 192. This will be 192 by 3. That will be 64 kilometers per hour. Because speed, average speed in this entire duration, the entire travel would be 64 kilometers per hour. Even though the distance has not been given, they have given us something, some part of the distance and the rest of the distance with some relation between them. So this is 1/4 of the distance, that's 3/4 of the distance. With that we can look at the ratio of the distance and then solve for it. Not a big deal. Instead, if they say one part of the distance and other part of the distance, I would have been worried. We need something more to do it, but you will get a lot of questions on this format, onward and return, which means distances are same. You have to interpret the data and then solve for it, right? We'll hop on to the next question and then I'll step away for a second. And let's go solve this now. An express train moving at 90 kilometers per hour crosses a goods train of length 900 meters moving in the opposite direction at 54 kilometers per hour in 30 seconds. Find the length of the express train. So we are looking at two trains crossing in opposite direction. So automatically I read the condition that says there are two trains traveling in the opposite direction with some distance and some speed. My mind should automatically say T is equal to D1 plus D2 divided by S1 plus S2. Why S1 plus S2? Opposite direction. That's important. So the time given here is 30 seconds. The length of the goods train is given as D1. Let's call it to be 900 meters. The speed of the goods train is 54 kilometers per hour. D2 is not given, but S2 is given to be 90 kilometers per hour. So my relative speed will be 90 plus 54, which will be 144 kilometers per hour. But I notice that time is given in seconds, length is given in meters. So I would rather turn this into meters per second, so that will be convenient for us. So into 5 by 18. 144 beautifully gets cancelled in 18. That would be 8 times. That would be 40 meters per second. Now let's plug in all the data that we have into the formula and then we are through. So what will you get? 900 plus D2 divided by 40 is equal to the time given is 30 seconds. So 900 plus D2 is equal to 1200, or D2 will be 300 meters. So the length of the goods train would be 300. Length of the express train would be 300 meters, and that's our answer. So the key is to understand the condition and then plug in the necessary formula to solve for it. If you know how to interpret the condition, if you know what to apply, it gets a lot easier from that, right? We'll hop on to the next question. A nice question. Have a look at it. Let's step away for a second once again. Let's have a crack at this now. Question says a train crosses a signal post in 12 seconds and a bridge in 20 seconds. If the speed of the train is 54 kilometers per hour, find the length of the bridge. So there's a train that is crossing a pole and a bridge. The speed of the train is given, time taken to cross the pole and the bridge is given. They are asking the length of the train. Let's go for it. Fine, length of the bridge is being asked. Now let's do this. So when a train crosses a pole, time taken will be d by s. Since you are dealing with two distance, train's distance and the bridge distance, I'm going to call it d1 by s. Or d1 is the length of the train. The speed of the train is given as 54 kilometers per hour. So multiplied by 5 by 18, we'll get 3, which is 15 meters per second. So d1 is equal to s into t. d1 is equal to, the speed is 15 meters per second. Time taken to cross the pole is 12 seconds. So that's into 12. So d1 is equal to 180 meters. We have the length of the train as 180 meters. Let's plug it in the next case to find the length of the bridge. So train crossing a bridge would be t is equal to d1 plus d2 divided by s. So here the time, let me call this t1, I'll call this t2. d1 plus d2 is equal to s into t2. We know the length of d1 is 180. 180 plus d2 is equal to 15 into 20. d2 is equal to 300 minus 180. d2 is equal to 120 meters. So the length of the platform is 120 meters. That's the way you get it done. But then the other way of looking at this, in a logical way of doing it, in a world where it's filled with logics, the one nice way that I look at this question and then solve it in like a step is the fact that I notice that the train takes 12 seconds to cross a post. So there is a post and then there's a train crossing it. What is the distance that the train is crossing? Its own distance, right? Train is crossing its own distance in 12 seconds. And then it takes 20 seconds to cross a bridge. Now we know that out of this 20 seconds, 12 seconds is to cross its own distance anywhere. At any given point, 12 seconds is to cross the length of the train itself. So what is the time taken to cross the platform, the bridge now? 8 seconds extra. I can say in 12 seconds, it can cover d1 distance. In 20 seconds, it can cover d1 plus d2 meters. Or I can think about this as, this 20 can be written as 12 plus 8 to cover d1 plus d2. So the 12 will be for d1, the 8 will be for d2. So the train can cover the length of the bridge in 8 seconds at 15 meters per second, or I will straight away say d2 is equal to 8 into 15, that will be 120 meters. A simple yet an effective way to look at it and say, hey, I can get the answer in a step or two. Now, you might not get questions exactly like this in your paper. The chances are very rare. But then, grasping logics to simpler questions will help us to frame a logic for questions that are slightly getting more complicated. So the key is to apply a logic that's foolproof everywhere. Have a look at it. Try using these logics in some of your questions and then see where it takes you. If you're comfortable, I strongly recommend that you continue with it. If you feel like, hey, I like the logic but it's not happening to me naturally, feel free to use a conventional way of doing it. At some point you will start getting better and you will move on to these ideas, and that's not a problem. So we'll go to one more question now. I'll give you another few seconds to take a snap of this. So let's have a look at the question. So the question says a boat travels between two towns 120 kilometers apart. The downstream journey and the upstream journey together take 10 hours. The speed of the stream is 5 kilometers per hour. Find the speed of the boat in still water. So we know that downstream time for downstream is equal to d divided by u plus v. Time taken for upstream is equal to d divided by u minus v. We know distance is equal to 120 kilometers. Speed of the boat is not given. Speed of the stream is given as 5 kilometers per hour. Total time is given as 10 hours. So let's plug in. Total time is downstream time plus upstream time put together is 10 hours. So plug it in. We'll get 120 by u plus 5 plus 120 by u minus 5 is equal to 10. I can take this 120 over here. 0, 0, 0 gets cancelled. 1 by u plus 5 plus 1 by u minus 5 is equal to 1 by 12. Taking out 120 common, taking it over here, cancelling out the zeros, you will get this. Now let's take LCM here. You will get u minus 5 plus u minus 5 divided by u square minus 25 is equal to 1 by 12. Minus 5 plus 5 gets cancelled. So you will have 2u by u square minus 25 equal to 1 by 12. Cross multiply. U square minus 25 is equal to 24u. U square minus 24u minus 25 equals to 0. The product is minus 25, sum is minus 24. Minus 25 plus 1 works. So you will say u minus 25 into u plus 1, or u is equal to 25 or 1 minus 1. Negative speeds not possible. Also, speed of the boat cannot be lesser than the speed of the stream. You have to understand two things here. Speed of boat can never be lesser than speed of stream. In the upstream case, the boat will never move. So speed of boat should always be greater than speed of stream. Two reasons to eliminate it. One, it is negative. Two, it is lesser than the stream speed. So can't be happening. So u is equal to 25, and that will be our answer. So, nice idea to hop on to. Hang on, get that idea, and we will fly. So try all these questions, or anytime you look at a question like this, try applying these logics to solve them and see if it works for you. If you have any questions, doubts, feel free to shoot your questions. Yes, and then obviously join the Telegram channels, scan the QR code. I'll step again once again for you to take snaps. So have fun learning, have fun solving. We'll learn a lot more. We have a few more classes happening in the same series, and we'll get to see you there. All the best, folks.